Today we will be discussing bridge forces, or the forces that act upon a bridge at any given time. There are four main forces that will act upon a bridge at any given time, and those are tension, compression, torsion, and shearing. Tension is defined as a pulling force. Compression is a pressing or squeezing force. Torsion is a twisting force. And shearing is a cutting force. A great example of tension is a rubber band. So when you take a rubber band and you pull it out nice and wide, what you're creating is more tension on that rubber band. If you actually strum or you flick that rubber band, you're going to notice that there's a very high pitched sound to it. If you take all the tension out of it, you're going to hear a much lower sound. Okay, this is why with any guitar or any string instrument in the orchestra, they can tune their strings to create either a higher pitched sound or a lower pitched sound by just changing the tension on that rubber band. The next thing we're going to discuss is compression. And compression was defined as a squeezing or a pushing force. What you see here is somebody pressing or squeezing toothpaste. What ends up happening is the toothpaste ends up coming all at the top and you got a big mess. So what you'll see is that the center will have nothing left in it, and the bottom and the top is where that toothpaste will be squeezed in the direction of. When we discuss these two forces when it comes to a bridge, this is a great example here. We have a truss bridge. A truss bridge is a bridge built out of a series of triangles. So you can see that the tension is at the bottom of the bridge, as well as all the cross members of the bridge, while the tension is the top of the bridge and all the vertical pieces. So what you see is actually the tension is pulling, which is creating a longer bottom, and the compression is pushing from the top, which will actually shorten up the top pieces at the end of the day. We have torsion here, which is a twisting force, and that's when a bridge is going to move from left to right. And what you see in the picture here is an example of the Tacoma Narrow. The Tacoma Narrow was built, and in the first week it began to turn left and turn right, and the bridge ended up failing over time because the span, which is the distance between two piers, was too great for the suspension bridge. Last but not least, here we have shearing. Shearing we defined as a cutting force. So when you take a pair of scissors and you cut through something, that is a shearing process. You could also take a saw and cut through any type of wood. That would be considered shearing also. So when the Tacoma Narrow Bridge failed, what you saw was it sheared down the middle because there was too much torsion. So that's how all these forces work together, sheared down the middle, and then the whole thing went into the water. I hope you enjoyed the lesson today. Have a nice day.